How are imaginary numbers used in electrical engineering?
Imaginary numbers are used in electrical engineering because complex numbers are an integral part of electrical problems. In fact, there are often more imaginary numbers in electrical engineering problems than there are real numbers. This is because a complex number is a pair of numbers in which one number is real. The other imaginary, or a real number multiplied by the value I, defined as the square root of -1. For more information about imaginary numbers, see Math Basics. For instance, we know electricity flows through an electrical circuit component such as a light bulb. The bulb actually resists the flow of some electricity by doing work or shining thus. The current is real and measured by a current meter. But if the current can't flow through a device, the current becomes imaginary. For example, a capacitor is two pieces of metal that do not touch. Therefore, if one adds a voltage, no real current can flow through it.
What is mathematical logic?
Mathematical logic is not the logic of mathematics, but is really the mathematics of logic composed of those parts of logic that can be modeled mathematically. Overall, it was invented to understand and present the work of Austrian-American mathematician and logician Kurt Gödel. 1906 to 1978, and his interpretation of the foundations of mathematics in the early 20th century. Although mathematicians use mathematical logic to have rational and reasonable discussions of the many issues in the foundations of mathematics, not everything is agreed upon.
What is the difference between probability and odds?
Probability is usually expressed as a fraction, sometimes as a percentage. For example, if there are 10 pieces of fruit in a jar, 3 apples and 7 oranges, then the probability of taking out an orange is 7/10, or 7 chances of an orange out of a total of 10 chances. On the other hand, odds are expressed as the number of chances for or against, versus the number of chances against, or for. Thus, if there are 3 chances of picking an apple and 7 chances of picking an orange, the odds are 7 to 3 against you picking an apple. Just reverse this to find the odds in favor, or, in this example, the odds would be 3 to 7 in favor of picking an apple. In order to convert the odds to probability, just add the chances. Thus, if the odds against a horse winning the Kentucky Derby are 4 to 1, that means that out of 5, or 4 plus 1, chances, the horse has 1 chance of winning. That makes the probability of the horse winning 1/5, or 20%.
What does the term statistically significant mean?
For most of us, significant means important. In statistics it means probably true, not due to chance, but not necessarily important. In particular, significance levels in statistics show how likely a result is due to chance. The most common level one thought to make it good enough to believe is 0.95. Which means the finding has a 95% chance of being true. This can also be misleading, however. No statistical report will indicate a 95%, or 0.95, in its answer. But it will show the number 0.05. Thus, statisticians say the results in a backward manner. They say that a finding has a 5% chance of not being true. To find the significance level, all one has to do is subtract the number shown from 1. For example, a value of 0.05 means that there is a 95%, 1. 0.5 equals 0.95, chance of it being true. For a value of 0.01, there is a 99% chance. 0.01 equals 0.99, of it being true, and so on. Bar graphs are similar to histograms, but with the columns separated by each other by small distances. They are commonly used for qualitative variables. A pie chart is another way to represent data graphically. In this case, it is a circle divided into segments, or pie wedges. Each segment represents not only a certain category, but its proportion to the total set of data. Another type of graph is the line graph, which is similar to those seen in geometry. A representation of the data from connected point to connected point. They are one of the most common graphs seen for simple statistical data collection.
How is unit price used to determine total price?
The unit price is simply the cost for each item, or unit. The term is often used to compare the cost of the same quantity of items that come in different sizes. Or it is used to determine total costs for services. For example, if a person was having a birthday party at a local restaurant for 100 guests, and each meal unit costs $7.50, the total cost of the celebration would be $7.50 x 100 equals $750. Add a tip to the total. See above, and it's easy to see why most people celebrate at home or only invite a few friends.
How long does it take for the sun's light to reach the Earth?
Because the sun is an average of 93 million miles, 149,598,770 kilometers, from the Earth. And the speed of light is approximately 186,000 miles per second, it is easy to determine the approximate time t it takes for the sun's light to reach the Earth using mathematics. T equals 93 million miles / 186,000 miles per second equals 500 seconds, miles cancel each other out, equals 8. Minutes.
What is a point spread?
A point spread is the predicted scoring difference between a game's two opponents. It is used by bookmakers to equalize two teams for betting purposes. For example, if a person chooses the team that is favored, the gambler has to win by more than the point spread in order to get credit for a correct pick. If the underdog team is chosen, the bettor must lose by less than the spread number in order to get credit for a correct pick. If a point spread is listed as off, this means there is no official point spread for the game. For example, if a person picks Army to win, and the team is favored to beat Navy by 5 points, called a spread of 5 points, Army must win the game by 6 or more points in order for the bettor to win. If Army wins by exactly 5 points, the game is called a push, and no one wins.
What is a quadratic equation?
A quadratic equation is a second-degree, order, polynomial equation. Thus it is guaranteed to have two solutions, both of which may be real or complex. This is seen in the standard form x2 plus bx plus c equals 0.
What culture took the first steps in the development of mathematical analysis?
Mathematical analysis and, thus, the ideas of calculus took centuries to develop. Probably the first to present some solid concepts in the field were the Greeks, whose most important contribution was the method of exhaustion, expanding the measurements of an area to take in more and more of the required area. For example, Zeno of Elea, c. 490–c. 425 BCE, based many problems on the infinite. Leucippus of Miletus, fluid c. 435–c. 420 BCE, Democritus of Abdera, 460–370 BCE. A student of Leucippus who also proposed an early theory about how the universe was formed, and Antiphon, c. 479–411 BCE, who some historians believe tried to square the circle, would all contribute to the method of exhaustion. Eudoxus of Cnidus, c. 400–347 BCE, would be the first to use the method on a scientific basis. Archimedes, c. 287–212 BCE, Hellenic. Considered one of the greatest Greek mathematicians, took mathematical analysis one step further. He more fully developed the theory presented by Eudoxus that would eventually lead to integral calculus.
What is a statistical test?
A statistical test is a procedure used to decide if an assertion, often called a hypothesis, about a population's chosen quantitative feature is true or false. These tests usually entail drawing on a random sample, or simple random sample, from the chosen population, then calculating a statistic about the chosen feature. From the result, a statistician can usually determine if the hypothesis is true, false, rare, common, or something in between. Overall, for a statistical test to be valid, it is necessary to choose what statistic to use, what sample size, and what criteria to use for rejection or acceptance of the tested hypothesis.
What is a magic square?
A magic square is an array of numbers in an n by n square that contains positive integers from 1 to n2 with each number occurring only once. The numbers in the squares are arranged so that the sum in any horizontal, vertical, or main diagonal direction is always the same. This is shown in the following formula: n2 plus 1, / 2. Magic squares are often divided into orders. For example, a 3-order magic square means 3 boxes per row and 3 boxes per column. In reality, magic squares are actually matrices. For more information about a matrix, see algebra. They can be odd order, such as a 3 by 3, or 5 by 5 matrix, or even order, such as a 4 by 4 or 6 by 6 matrix, magic squares. Perhaps the simplest magic square is the 1 by 1 square, whose only entry is the number 1. Such magic squares have been known for centuries. For example, the Chinese knew about the 3 unique normal squares of order 3. In Chinese literature dating from as early as 2800 BCE, a magic square known as the Lo Shu, or scroll of the river Lo, was invented by Fa Hai, who is thought of as the mythical founder of the Chinese civilization.
What do the numbers on gas and electric meters measure?
Gas and electric meters measure the daily gas or power usage, usually of a house or other building. The standard electric meters are clock-like devices that record the amount of usage. As a house or business draws on the electric current, a set of small gears inside the meter move. The number of revolutions are recorded by dials in the meter, with the speed of revolutions determined by the amount of power consumed. Newer digital models record power usage digitally. A gas meter measures the amount of gas used by a home or business. In this case, the meter measures the force of the moving gas in the pipeline. The dials on the meter turn faster as the flow of gas increases, or slower as the gas flow decreases. To understand how the gas and electric companies charge a customer takes only an understanding of simple mathematics. In both cases, the difference between 1 month's reading and the next month's reading is the amount charged. For example, if the electric current reading is 3240 and the previous month's reading is 3201. The amount of electricity used is 39 kilowatts for 1 month. Then the company multiplies the number of kilowatts by the amount per kilowatt hour to arrive at the charge to the customer.
What are the multiplication rules of probability?
In probability theory, the multiplication rule is used to determine the probability that two events, A and B, both occur. As with the addition rules, the notation for multiplication rules of probability are most commonly seen in terms of sets. P, A and B, equals P, A B, P, B, or P, A and B, equals P, B A, P, A, in which P, A represents the probability that event A will occur, P, B, represents the probability that event B will occur. And P, A and B, is translated as the probability that event A and event B will both occur. In addition, P, A B, is the conditional probability that event A occurs given that event B has already occurred. And P, B A, is the conditional probability that event B occurs given that event A has already occurred. Similar to the addition rules, if there are independent events, or those that have no influence on one another, the equation reduces to P, A and B, equals P, A, P, B.
What is arithmetic progression?
Arithmetic progression is one of the more simple types of series in mathematics. It is usually in the form of A and D, A plus 2D, A plus 3D, and so on, in which A is the first term and D is the constant difference between the two successive terms. A progression is also seen as these numbers are added. As in A plus, A and D, plus, A plus 2D, plus, A plus 3D, plus, A plus, and plus 1, D. An example of an arithmetic progression would be 2 plus 6 plus 10 plus 14 plus, in which D is equal to 4.
What are some of the common metric/SI prefixes?
The common metric and SI prefixes have been around for a while, but some were only recently added. In 1991, in order to apply standard units, SI units, see above, to a wide range of phenomena. Especially in the scientific world, the 19th General Conference on Weights and Measures lengthened the list to accommodate larger and smaller, metric numbers, with the list now reaching from Yate to Yocto dash.
How are some stock market financial indicators calculated?
There are numerous financial indicators associated with the stock market, and they all have to do with mathematical calculations. Dividends are taxable payments put forth by a company's board of directors and distributed to its shareholders. These monies come from the company's current or retained earnings and are usually paid out every quarter. They can be either in the form of a cash dividend, usually in check form, stock dividend, or other property. The dividend yield is the yield paid out by a company to shareholders in the form of dividends, calculated by the amount of dividends paid per share over a year, then divided by the stock's price. For example, if a stock pays out $2 in dividends over the course of a year and trades at $40, the dividend yield is 5%. The P/E ratio stands for price/earnings ratio, a measure of a stock's amount to its earnings per share. It is a measure of a stock's market capitalization, divided by its after-tax earnings over a 12-month period. The higher the P/E ratio, the more the market is willing to pay for each dollar of annual earnings. Of course, companies with negative earnings, or those that are not profitable, have no P/E ratio at all.
Who was Gregor Mendel?
Austrian monk Gregor Johann Mendel, 1822–1884, performed experiments with pea plants. From 1857 to 1865 that eventually led to his discovery of the laws of heredity. Gathering 34 different kinds of peas of the genus Pisum, all tested for their purity. He attempted to determine the possibility of producing new variants by crossbreeding. By self-pollinating the plants and covering them over so there was no unplanned cross-pollination, he determined the detailed characteristics of their offspring, such as height and color. Prior to Mendel, scientists believed that heredity characteristics of a species were the result of a blending process, and that over time various parental characteristics were diluted. Mendel showed that characteristics actually followed a set of specific hereditary laws. He worked out what can be described as a mathematical matrix of the characteristics, thus determining what characteristics were dominant and recessive in the plants. For more about matrices, see algebra. But Mendel had a hard time getting his results published. Even after publication by a local natural history society, his work was ignored. Mendel gave up both gardening and science when he was promoted to abbot. Coincidentally, and amazingly, by 1900 3 different biologists working in 3 different countries, Hugo de Vries in the Netherlands, Erich Tschermak von Seisnig in Austria, and Karl Correns in Germany, determined the hereditary laws independently. But they all knew about Mendel's work, graciously giving the credit for the findings to him. Mendel, rightfully, is now commonly considered the father of genetics.
What are some examples of Egyptian multiplication?
Egyptian multiplication methods did not require a great deal of memorization. Just a knowledge of the 2 times tables. For a simple example, to multiply 12 times 16, they would start with 1 and 12. Then they would double each number in each row. 1x2 and 12x2, 2x2 and 24x2, and so on. Until the number 16, resulting in the answer 192, another example computes a number that is not a multiple in the row. Such as 37 times 19, first, do the usual procedure by starting with 1 and 19, then doubling the numbers until you get to 32, if you double 32 equals 64, you've overshot the number 37. Because 37 is higher than 32, go back over the list on the left-hand side, figure out which numbers. With 32, add up to 37, 1, 4, and 32, then add the numbers that correspond to those numbers. To the right, 19, 76, and 608, which equals the answer, 703. And you didn't even need a calculator.
How is math used to understand chemical reactions?
One of the simplest examples of mathematics used in understanding chemical reactions is based on 2 chemicals, A and B. They can be molecules or ions. If A and B encounter one another, they can rearrange themselves into molecules or ions of 2 other substances, in this example, C and D. The reaction that takes place can give off or absorb energy, making the molecules move faster or slower. Although this is a simple example of what can happen in a chemical reaction, it can still be analyzed using mathematical modeling.
Are there different types of infinity in mathematics?
To most of us, the universe represents infinity. But in mathematics it is the unbounded quantity that is greater than every real number. Called potential infinity in mathematics, it is the potential for infinity that exists with natural numbers, because one can always conceive of a number greater than any given number. Another type of infinity in mathematics is completed infinity, which refers to the size of an infinite set, such as all the points on a line. At the end of the 19th century, German mathematician Georg Ferdinand Ludwig Philipp Cantor (1845 to 1918) showed that different orders of infinity existed, and that the infinity of points on a line was of a greater order than that of prime numbers.
Did Einstein's theories change our concept of dimensions?
Yes, our ideas about dimensions changed dramatically thanks to Einstein's theories. Not to mention the mathematics involved in producing those theories. In particular, one can't distinguish space and time as elements in the description of events. Instead, they are joined in what is called the fourth dimension also. Called a four-dimensional manifold known as spacetime, see above. Although it sounds like something out of the television show Star Trek. In spacetime, events in the universe are described in terms of the four-dimensional continuum. Simply put, each observer locates an event by three space-like coordinates, positions, and one time-like coordinate. The choice of the time-like coordinate in spacetime is not unique. Hence, time is not absolute but is relative to the observer. The strange effects go on, in general, events at different locations that are simultaneous for one observer will not be simultaneous for another observer. For more information about dimensions, see geometry and trigonometry.
What is a stock market or stock exchange?
The stock market, or stock exchange, is a way of providing companies a means of issuing shares to people who want to invest in various companies. It provides a way of buying and selling those shares. Stocks, or the ownership investment in a corporation, is represented by shares, which are claims on a company's assets and earnings. Common stock means the investor has voting rights in the company. Preferred stock means there are no voting privileges. Owners of preferred stock, however, have first claim not only on the assets and earnings of the company over common stock, but also the dividends are paid first to people who own these shares.
What is an ordered pair?
An ordered pair is two quantities usually written as A, B, that have a significant order, thus, A, B, does not equal B, A. Ordered pairs are used in set theory to define members in a function. Ordered pairs are also valuable in linear equations and graphing, in which the x-coordinate is the first number and the y-coordinate is the second number, or x, y. They are used on a grid to locate a point. For more information about ordered pairs and graphs, see geometry and trigonometry.
What is an aerospace engineer?
Aerospace engineers are directly involved with putting objects from airplanes and the space shuttle to deep spacecraft into the sky and beyond. Using sundry mathematical models and techniques, they install, construct, maintain, and test systems used to launch, diagnose, or track aircraft and space vehicles. They may calibrate test equipment and determine causes of equipment malfunctions. Using computers and communication systems, aerospace engineers often record and interpret test data.
How does one sample a population?
Sampling is the term used when one obtains a sample of a population. The number of members in the sample is called the sample size. As with most mathematical concepts, there are several types of sampling. Random sampling is a technique involving a group of subjects, the sample, from a larger group, population. It is a method that reduces the likelihood of bias. In random sampling, each individual is chosen by chance, with each member of the population having a known, but often unequal, chance of being included in the sample. Simple random sampling also involves a group of subjects, the sample, from a larger group, population, but in this case, each individual is chosen entirely by chance, with each member of the population having an equal chance of being included in the sample. In fact, each member of the population has an equal chance of being chosen at any stage of the sampling process. Independent sampling comprises samples collected from the same or different populations that have no effect on one another. In other words, there is no correlation between the samples. Stratified sampling includes random samples from various subgroups, also called subpopulation or stratum of the population, chosen to be representative of the whole population. It is often thought of as a better technique than simple random sampling. For example, if a sheep farmer wanted to determine the average weight amount of wool gathered from 3 types of sheep on his farm, he could divide his flock into the 3 subgroups and take samples from those groups. In cluster sampling, the entire population is divided into clusters, groups, then a random sampling is taken of the clusters. This technique is used when a complete list of the population's members can't be studied, but a list of population clusters can be gathered.
What is the graphic representation of the approximation of an area under a curve using integration?
It's easier to see the approximate area under a curve using integration by means of graphs. It all has to do with rectangles. The idea is to extend lines from the ends of the curve, here, f, x, to the z-axis, or y-axis, depending on the curve. We'll call the total area under the curve n, then divide the entire area under the curve into equal width sections. x1, x2, x3, and so on, that are equal to parts of n, the subregions n1, n2, and so on. The next step is to figure out the area of a rectangle if each section was cut off below the curve and then above the curve. This creates rectangles defined by left-hand right endpoints. From the left-hand right sums, and a few more calculations, we can approximate the area of n.
What's the connection?
Because logarithms are really exponents, they satisfy all the usual rules of exponents. Consequently, tedious and long algebraic calculations such as those involving multiplication and division can be replaced by the simpler processes of adding or subtracting the corresponding logarithms. In general, logarithmic tables are usually used for this purpose, although calculators, computers, and the Internet often replace the need for such tables.
What is money?
Actually, money is a mathematical concept. In each culture, money, or currency, is the most common medium of exchange. And through an agreement within a community it can be traded and exchanged for goods, services, or obligations. Each type of currency represents specific units that can be subdivided, such as dollar bills and quarters. A good or service is then given a certain value when compared to other goods and services. What is usually referred to as a price. Because of this, people who use money need to know some of the most basic of mathematical concepts, especially addition and subtraction. Of course, money is actually an abstraction. Now and over the centuries, it has been essentially a token. That is why money has often been represented by such things as naturally scarce precious metals, such as gold and silver, conch shells, trinkets, and today's entirely artificial representation of money, paper banknotes.
What are some of the basic building blocks of geometry?
There are several basic building blocks of geometry, all of which have to do with the objects we often see in geometry. A zero-dimensional object that is specifically located in n-dimensional space using n coordinates is called a point. The idea of a point may be obvious to most people, but for mathematicians, describing and dealing with points is not straightforward. For example, Euclid once gave a vague definition of a point as that which has no part. Euclid also called the line a breadthless length, and further called a straight line one that lies evenly with the points on itself. Modern mathematicians define lines as one-dimensional objects, although they may be part of a higher dimensional space. They are mathematically defined as a theoretical course of a moving point that is thought to have length but no other dimension. They are often called straight lines, or by the archaic term, a right line, to emphasize the fact that there are no curves anywhere along the entire length. It is interesting to note that when geometry is used in an axiomatic system, a line is usually considered an undefined term. For more about axiomatic systems, see Foundations of Mathematics. In analytic geometry, a line is defined by the basic equation x plus y equals c, in which a, b, and c are any number, but a and b can't be zero at the same time. A line segment is the shortest curve which is actually straight to connect two different points. It is a finite portion of an infinite line. Line segments are most often labeled with two letters corresponding to the endpoints of the line segment, such as A and B, and written as a B. Distance is the length of the path between 2 points, or the length of a segment, for example, between points A and B. When talking about the distance between any 2 points associated with A and B as real numbers, on a number line, distance becomes the absolute value of BA. Another basic building block is the ray. Think of a ray as a laser beam. It originates at one point and continues in one direction toward infinity. A ray is defined as part of a line on one side of a point, and includes that point. Two letters are needed to name a ray. For example, ray of is defined by point A, where it begins, and point B, the point the ray goes through. But note, ray of is not the same as ray BA. If the initial point is not included, the resulting figure is called a half-line. In geometry, a ray is usually considered a half-infinite line, with one of the 2 points A and B taken to be at infinity.
Who was considered the first statistician?
English statistician and tradesman John Grunt, 1620 to 1674, was the first true statistician and wrote the first book on statistics. Although statistics in a simpler form was known long before that. Grunt, a draper by profession, was the first to use a compilation of data, which in this case involved the records of bills of mortality, or the records of how and when people died in London from 1604 to 1661 in his natural and political observations made upon the bills of mortality. He determined certain inclinations, such as more boys were born than girls, women tend to live longer than men, etc. He also developed the first mortality table, which showed how long a person might expect to live after a certain age. A concept very familiar to us today, especially in fields such as insurance and health.
What are the ways to convert between AM and PM and 24-hour time?
When converting AM/PM to 24-hour time for the hours between 12 AM and 12:59 AM. Just subtract 12 from the time. For instance, 12:45 AM minus 12 will equal 0045, and 12:59 AM minus 12 will equal 0059 times between 1 AM and 12:59 PM are a straight conversion, such as 9 AM equals 0900 and 11 AM equals 1100. For the conversion between 1 PM and 11:59 PM, add 12, such as 8:34 PM plus 12 equals 2034, and 11:59 PM plus 12 equals 2359, also seen as 2034 and 2359. To convert in the opposite direction from the above, add 12 for the hours between 0000, midnight, and 0059, such as 0034 plus 12 equals 12:34 am, and 0059 plus 12 equals 12:59 am. 2. Convert from 0100 to 1159 and from 1200 to 1229, there is a 1-to-1 conversion. The former to AM and the latter to PM. For example, 0100 equals 1 AM, 0345 equals 3:45 AM, 1235 equals 12:35 PM. And 1259 equals 12:59 PM. To convert between 1300 and 2359, subtract 12, such as 1424 minus 12 equals 2:24 PM. And 2359 minus 12 equals 11:59 PM. How are local A.M/P.M?
What is the beast number?
The so-called beast number is 666, a number that is mentioned in Revelations 13:18, here is wisdom. Let him that hath understanding count the number of the beast. For it is the number of a man, and his number is 666. It is also thought of as the number of the Antichrist. There are other related numbers that have gained cult aspects, too. For example, a number having exactly 666 digits is called an apocalypse number. A number of the form 2n that contains the digit 666, in other words. Powers of 2 that contain 3 consecutive 6s in the decimal representation is called an apocalyptic number. 2157 is one such number. It equals 182,687,704,666,362, 864,775, 460, 604, 089, 535, 377, 456, 991, 567, 872. The first few such powers are 157, 192, 218, 220, and so on. There are also some interesting mathematical characteristics of the beast number that mathematicians have found as they played with numbers. For example, the beast number is equal to the sum of the squares of the first 7 primes. Or 22 plus 32 plus 52 plus 72 plus 112 plus 132 plus 172 equals 666. It's a sum and difference of the first 3/6 powers. 1626 plus 36 equals 666. There are exactly 2 ways to insert plus signs into the sequence of 1 2 3 4 5 6 7 8 9 to make the sum 666, and exactly 1 way for the sequence 9 8 7 6 5 4 3 2 1, 1 plus 2 plus 3 plus 4 plus 567 plus 89 equals 666. 123 plus 456 plus 78 plus 9 equals 666. 9 plus 87 plus 6 plus 543 plus 21 equals 666. Even more amazing is that the Dewey Decimal System classification number used in libraries for numerology is 133.335, reverse the number and add to get 133.335 plus 533.331 equals 666.666 and. Just as weird, if you write the first 6 Roman numerals, in order from largest to smallest. You get 666, Txi equals 666. In Indian numerology, for example, everyone has 3 relevant numbers that explain and predict human behavior. Psychic, destiny, and name numbers, and they mean something different to each person. In Norse numerology, 3, 9, and multiples of 3 and 9 are magically potent. For example, the number 9 is significant in Norse magical practice and often points to Odin. Considered the supreme god in Germanic and Norse mythology, Odin, legend says, hung himself from a tree for 9 days and nights, a time in which he learned 9 magical songs and 18 magical runes. In addition, there were 9 realms of existence, 40 Norse Valkyries, and 13 Norse gods were present when Loki caused the death of Baldur. In China, the number 3 is lucky, and 8 is even luckier. 6 and 9 also run close behind. The number 6 implies that everything will go smoothly. 8 was originally favored by the Cantonese, since in their language 8 means to make a great fortune in the near future, later. The Chinese favored the number 9 implies something everlasting, especially in friendship and marriage. Numbers ending in these digits are often favored today when Chinese people choose phone numbers, room numbers, and car licenses. As for unlucky numbers, 4, unlucky also in Japan, and 7 are at the top of the list. The former implying death and the latter meaning gone. 14 is also bad news. In fact, some cities in China ban the number from car licenses, and many buildings do not have 4th and 14th floors.
What are independent events in probability?
In probability theory, events are independent if the probability that they occur is equal to the product multiply together of the probabilities of either 2 or more individual events. This is also often called statistical independence. In addition, the occurrence of one of the events can give no information about whether or not the other event, S, will occur, that is, the events have no influence on each other. For example, 2 events, A and B, are independent if the probability of both occurring equals the product of their probabilities, or P, A, P, B. The symbol is often used to depict the product of the events in probability theory. One good example involves playing cards. If we wanted to know the probability of 2 people each drawing a king of diamonds, 2 independent events, it would be defined as A equals 1/52, the probability that one person will draw a king of diamonds, and B equals 1/52, the probability that the other person will draw a king of diamonds. Assuming the first person puts the first drawn card back into the deck, Substituting the numbers into the equation, the result is 1/52 equals 0.00037. Or a slight chance that both people will draw the king of diamonds from the deck.
What are triangles and how are they classified?
Triangles, or three angles, are polygons with three sides. A triangle's three line segments, or sides, are joined together at three vertices, endpoints. For all triangles, the sum of a triangle's three interior angles is equal to a straight angle, or 180 degrees. Triangles are classified by either the lengths of their sides, or, more commonly, the measurement of their angles. All triangles have at least two acute angles, but the third angle, which can be used to classify the triangle, can be acute, right, or obtuse. For more about these angles, see above. The types of triangles based on angles are: right triangle, there is one angle of 90 degrees. Acute triangle, all three angles are less than 90 degrees, or the triangle has three acute angles. Obtuse triangle, there is one angle greater than 90 degrees, or the triangle has one obtuse angle. Equiangular triangle, an acute triangle in which all angles are congruent, or when all three angles are equal. Triangles can be further classified by their sides, as in the following. Scalene triangle, there are no sides and therefore no angles that are equal, in other words, no sides are congruent. Isosceles triangle, two of the sides are equal, congruent, and thus the base angles are equal. Equilateral triangle, when all three sides are equal, congruent.
How was, and is, 1 second defined?
A second was once defined as 1/86,400 of a mean solar day. By 1956 this definition was changed by the International Bureau of Weights and Measures to 1/31,556,925.9747 of the length of the tropical year 1900. But like most measurements, the second definition changed again in 1964, when it was assigned to be the equivalent of 9,192,631. 770 cycles of radiation associated with a particular change in state of a cesium-133 atom. Interestingly enough, by 1983 the second became the definer of the meter. Scientists defined a meter as 1/299,792,458, the distance light travels in 1 second. This was done because the distance light travels in 1 second was more accurate than the former definition of the standard meter.
What is biology?
Biology is the science of life. It includes the study of the characteristics and behaviors of organisms. How a population, species, or individual comes into existence and evolves. And the interaction of organisms with the environment and each other.
What are algebraic equations?
An algebraic equation, as with the equations defined above, is a statement in which two numbers, letters, or expressions are equal. But algebraic equations take this idea even further, most of the time. The objective is to try to simplify the numbers and the one, or more, variables in the equation. These can further be defined as any combination of variables or constants linked together by any operation addition, subtraction, multiplication, division, except division by zero. This type of algebraic equation is often referred to as a polynomial. See elsewhere in this chapter for more about polynomials.
What are unit fractions and how are they tied to ancient Egypt?
A unit fraction is one that has a numerator of 1, such as 1/2, 1/4, and 1/43545. One of the earliest discussions of unit fractions, a table of representations of 1/n, was found on the famous Rhind papyrus. Also called the Rhind mathematical papyrus, dated to around 1650 BCE. This record a table copied by the Egyptians from another papyrus dated 200 years earlier represented a sum of distinct unit fractions for odd n numbers between 5 and 101. To write a certain fraction, they would add combinations of 1/n. For example, instead of writing 2/5, they wrote 1/3 plus 1/15, for 2/29, they wrote 1/24 plus 1/58 plus 1/174 plus 1/232. Because of the Rhind papyrus discovery, the sums of unit fractions are now called Egyptian fractions. No one truly knows why the Egyptians chose this method for representing fractions. But some historians believe it was a wrong turn in Egyptian mathematical history. Whatever the reason, the Egyptians, apparently successfully, used this system for 2,000 years. For more information about the Rhind papyrus, see History of Mathematics.
What does a priori refer to in mathematical modeling?
The term a priori refers to the amount of information available in a system. Based on the amount of a priori information, mathematical modeling problems are often classified into white box, a system in which all necessary information is available, or black box, a system in which there is no a priori information available, models. Practically all systems are somewhere between the white box and black box models, thus. This concept only works as an intuitive guide on how to approach a mathematical problem.
What are some applications of operations research?
Applications of operations research span a wide variety of fields, especially with regard to reducing costs or increasing efficiency. The following lists just a few examples: constructing a telecommunications network at low cost and top efficiency, especially when under high demand or after being damaged. Determining routes of school buses so fewer vehicles are needed, and designing a computer chip that will reduce manufacturing time.
What is a ring?
A ring is an algebraic structure, some definitions say a set, in which two binary operators, addition and multiplication, in various combinations must satisfy either the additive associative, commutative, identity, and inverse properties. The multiplicative associative property, or the left and right distributivity properties. For example, the elements of one operation, such as addition, must form a group that is commutative, also known as an abelian group. The multiplicative operation must produce unique answers that have the associative property. These two operations are further connected by requiring the multiplication to have a distributive property with respect to the addition. This can be written as follows, with A, B, and C elements of the ring. AX, B plus C, equals, AXB, plus, AXC, and, B plus C, XA equals, BXA, plus, CXA.
How does one determine the distance and amount of time a trip will take?
There are several ways to determine the distance and amount of time a trip will take. For example, if the traveler knows that his or her car travels 20 miles for every gallon of gas in the tank, he or she could represent the total number of miles it is possible to drive based on how much gas is put into the tank. This can be expressed as 20G, in which G stands for the number of gallons in the tank. For example, if someone bought 10 gallons of gas to reach a destination, 10 gallons x 20 miles/gallon, the traveler can go about 200 miles. The gallons in the top and bottom of the equation cancel each other out, leaving miles. Another example involves cars and mileage. If the traveler drives down a highway at a steady rate of 65 miles per hour, the driver can determine how long it will take to get to a destination, especially if he or she knows how many miles it is to that destination. The equation is mileage divided by 65 miles per hour, m/65. For example, if the traveler is going 650 miles, the 650 miles / 65 miles per hour equals 10 hours. The miles in the top and bottom of the equation cancel each other out, leaving hours.
What is a paradox?
In logic, paradoxes are statements that seem to be self-contradictory or contrary to one's expectations. These arguments imply both a proposition and its opposite. One of the most famous paradoxes was stated by English logician Bertrand Russell, 1872 to 1970, in 1901, and deals with sets. If sets that are not members of themselves are normal, is the set of normal sets itself normal?
What type of number system is used by modern computers?
Modern computers use the binary system, a system that represents information using sequences of zeros and ones. It is based on powers of 2, unlike our decimal system based on powers of 10. This is because in the binary system, another number place is added every time another power of 2 is reached. For example, 2, 4, 8, and so on, in the decimal system. Another place is added every time a power of 10 is reached, for example, 10, 100, 1000, and so on. Computers use this simple number system primarily because binary information is easy to store. A computer's CPU, central processing unit, and memory are made up of millions of switches that are either off or on. The symbols 0 and 1 represent those switches, respectively, and are used in the calculations and programs. The two numbers are simple to work with mathematically within the computer. When a person enters a calculation in decimal form, the computer converts it to binary, solves it, and then translates that answer back to decimal form.
What is the annual percentage rate, or APR?
The annual percentage rate, APR, is an expression of the yearly interest rate that will be paid on a loan, which includes credit cards. It differs from the advertised interest rate, as it includes one-time fees in an attempt to calculate the total cost of borrowing the money. Therefore, it is wise to always look for a low APR. Because lenders are required to disclose the APR before a loan or credit application is finalized, it makes it easier to compare lenders. For example, if a person borrows $100 for 1 year at 5% simple interest, they will owe $105 at the end of the year, and the lender charges a $5 fee. The total cost to borrow the money will actually be $10, meaning the APR is 10%.
What types of analyses interest engineers?
There are several types of analyses that interest engineers, all of which involve mathematical modeling. Structural analysis deals with linear and nonlinear models and stresses on a material. The linear models assume the material does not plastically deform, the remaining deformation after the load causing it is removed. Nonlinear models stress the material past its elastic capabilities. The stresses in the material then vary with the amount of deformation. Vibrational analysis deals with possible resonance and subsequent failure. It is used to test a material that may experience random vibrations, impacts, or shocks. Fatigue analysis is used to determine the life of a material or structure. It shows the effects of occasional, periodic, or cyclic loading on a structure or object, pointing out where cracks or fractures are most likely to occur. Engineers measure heat transfer to determine a material or structure's conductivity or thermal fluid dynamics. In this way, researchers understand how a material will respond to various hot and cold conditions, or even how it diffuses heat and cold over time.
How can word problems be expressed as equations?
There seem to be a gazillion word problems out there. Just ask anyone taking such tests in grade or high school. The one thing most have in common is that they can be expressed as an equation, many as algebraic equations in which there are known and unknown quantities. In almost all instances, there are keywords that lead the reader to determine not only the numbers and variables, but also what operations to use in the equation to determine the answer.
What are some physics fields that rely heavily on mathematics?
Almost every field of physics, especially modern physics, relies heavily on mathematics. For example, mathematics is needed to understand the concepts of acceleration, velocity, and gravitational forces. Statistical mechanics also uses an intense amount of mathematics, and it is impossible to comprehend quantum mechanics without a good knowledge of mathematics. In fact, the subject of quantum field theory is one of the most mathematically rigorous and abstract areas of the physical sciences.
What is propositional calculus?
Propositional calculus is not the calculus most of us hear about, but it is considered by many to be the foundation of symbolic logic. Actually, the term calculus is a generic name for any area of mathematics that deals with calculating. Thus, arithmetic could be called the calculus of numbers, also known as truth functional analysis, sentential calculus, or the calculus of propositions. Or, as seen above, any declarative sentence that is either true or false. Propositional calculus deals with statements that can be assigned truth values. In general, it uses symbols to denote logical operators, such as and or, and parentheses for grouping formulas.
How is the term surface used in mathematics?
When most of us think of the word surface, we often envision our own world, the thin outer crust of soil and rock we walk and live on. In engineering, the term means the outer part, or the skin with a thickness of 0, of a body. In science, it can apply to a plethora of objects, from geologic structures to micrometer-sized particles. In mathematics, surface also has numerous meanings. The most common denotes a two-dimensional topological space or three-dimensional Euclidean space. A surface in mathematics can be complicated and complex, such as in certain fractals, or extremely simple, such as in a plane.